This is NBHM solution, and today we'll be solving question number 32. So the question is given as, for a positive integer let fn of x r of 2r defined by f of n is x plus 1 by nx square. So for which of the following statement is true or false? The continuous function converges uniformly with this. So sequence of functions is convergent, obviously. Whether it is uniforming, that is also for sure. For these two parts, only the point we need to find out. Okay. So f of n of x is r to r. So f of n of x, we can take it as x 1 plus nx square provided. So let f of n of x equal to, limit n tends to infinity, equal to fx equal to 0 and 0. If fx equal to 0, if x not equal to 0, so ultimately it is 0 for all values of x in real value. So now we have a check on the fn of 0. So unit of fx or not. So mn test we can do for unit convergence. Okay, so for uniform convergence we can apply this. So mn equal to supremum of fn of x minus fx. So supremum of function of x, so x 1 plus nx square minus 0. So supremum equal to this thing. So now for supremum we put yn equal to 0 and then put x equal to 0 in terms of n. So yn dash x equal to 1 plus nx square, x to nx whole square. Whole square, this is equal to 0. So 1 minus nx square equal to 0. So x equal to 1 by root n. This will be giving you this. Now putting x equal to 1 by root n over here. So mn equal to supremum of 1 by root n 1 plus n by into 1 by n. So supremum equal to 1 by root n by 2, that tends to 0. Now by the mn test, fn is uniformly convergent. Okay, so option A, option B is okay, true. Now for option C and D, fn of x is 1 minus nx square after the first order derivative, 1 plus nx square whole square. Let n tends to infinity fn dash x. So equal to, let it be g1x, and 1 and 0 are two values for x equal to 0, and this is for x not equal to 0. So the limit, let me add an extra page here. So this limiting value of fn equal to supremum of 1 minus nx square divided by 1 plus nx square whole square minus 0. So supremum of this thing only. So we putting x square equal to 1 by n. So x equal to 1 by root n. So we have already discussed this. So supremum will become 1 minus n by 1 minus n, 1 n 1 by n. This is a supremum of 0 by 2, so 0 as n tends to infinity. So fn dash x is uniformly convergent in g1 of x as this thing. Then it is uniformly convergent in 1 to b also if b greater than 1. So obviously option number D is correct for this, and option number A, B, D are true. Option number C is false actually. So A is correct, B is correct, C is correct, and D is correct, and C is not applicable.